Yeah. So let us start our today's class. Okay. I think we learned up to schedulers and what are all the different types of scheduling algorithms we have. Scheduling queues we have. And also we learned about the last concept that we learned is about context switching. Context switching is nothing but how the CPU can be switching between the two or more processes to achieve multi-programming concept. I hope you all are clear with those concepts. So today we'll see what type of operations we're going to perform on these processes. You all know what actually a process is, right? In the earlier classes, while learning about the different types of system, like operating systems also, I told you like whenever we want to execute any task, it has to be copied into the main memory. So once it is copied into the main memory, it will be referred as a process, isn't it or not? So today on a process, like once it is copied into the main memory, what tasks are performed on the processes? Okay. So actually mainly categorized into two processes, like two operations will be performed on a process. You can make a note of those two operations. First one is process creation. Like mainly it is categorized like this. Internally, it will be having some sub classifications also. Okay. The first one is process creation and the second one is process termination. So we'll see in detail about what is process creation. So when a process is created, what are all the things it has to take care, and finally how a process can be terminated. Okay. So first we'll see about the process creation. So process creation is nothing but once a process has been copied into the main memory, then it will be created as a process. You all know that, right? Now, a process can create or a process can in turn help us to create one more process which will be referred as a child process. So first we'll see about process creation. In that you need to understand two terminologies. The first terminology is nothing but when a process is called as a parent class and when a process is called as a child process. Okay. So using a system called create process system call, a process may create n number of processes and in turn those processes can create another process. So we can say like one process creating three processes and again those processes will be creating in turn some more one or two processes, then it is referred as a tree structure. So always remember process creation will lead us in forming a tree of processes. Now the process which is creating the process is referred as a parent process and the process which is referring which has been created is called as a child process. Okay, so you don't think like we'll be having only one parent and one child process. It is not the case. Parent process will lead to the child process and this child process can in turn create another process. Like you can understand in this fashion. Suppose this is process P1. Okay. Now this process P1 can create another process, two processes. Let us consider process P1 is creating another process like P2 and P3. Okay. P2 and let us consider P3. So now we can say like P1 is a parent process for P2 and P3. When means for P1, P2 and P3 are child process. But it is not the case always. It can create more than two also. And similarly, P2 can still create two more processes or two or more processes which can be referred as child process for P1. Okay. For P1 and both P2 also. So let us refer this one as P4 and we can have one more process created like this. So P5, let us consider. So we can say it is like a tree structure, isn't it or not? So from here to here, we'll have connection like this. So we can say this is a tree structure. So always remember, even though they are creating multiple processes, like P1 is creating its own child process. Each process will have its unique identifier, and that unique identifier is called as an integer identifier. So that is an important point. Each process will have its unique identifier. You might be remember process control block. We have a field called process ID. So that ID is unique for even it is a parent child or a parent process or a child process. We have a unique ID that will be reflecting in the PCB. Okay. So that is called as unique identifier. Now, whenever a process is creating another process, there are something that will be commonly shared among this parent process and child process. Let us see what are all the things we need to consider. Okay, so the first thing is resource management, how the resources are managed, because we have limited resources. Like then when a parent child is creating when a parent is creating a child process, how the resources will be managed. So management is the first thing. So coming to the resource management, we can have three options here. The first option is the resources can be shared between between the parent and the child. Okay, the first thing is the resources can be shared. Second option is only parent can have the resources. Okay, and the parent, if the parent want, the parent can share some resources between the with the child. Okay, in the first case, all resources can be shared. But whereas in the second case, only parent shares some resources with child. That means here parent will be deciding what resources the child has to access. And the third one is no resources will be shared. Got it? So whenever resources are nothing but your whatever it can be your input output devices, okay, your files, whatever it can be. If you want to have a resource management, any one of these three can be assigned. We have an option to set these privileges also. Okay, so all resources can be shared. Like what are all the resources used by parent, the same resources can be used by child, or else we can have a constraint where parent can assign only some resources to be used by the child, or else no resources can be used. Okay, so the second important point we need to understand is execution option, how the execution is going to happen. So note down, the second point is execution. Sorry. Now in this execution process, again we have two options, where we can have an option where parent and child can be executed concurrently, like simultaneously. The CPUs will switch between the parent and the child. Okay, the first option is parent and child can be executed concurrently, where we can achieve multi-programming or multitasking feature. The second option is, and once a parent has created a child, the parent has to wait until and unless the child finishes. Okay, so that is the second option. Parent has to wait until child terminates. Understood? In the first case, the parent is different and the child is different. Even though the parent P2 is created by P1, they can be executed concurrently. No one is waiting for the other one to finish. But in the second case, we have some scenarios where until and unless P2 completes its task, once it gets a signal from the P2 saying like my work is done, then only P1 can be continuing or finishing its task. Got it? So that is the second way of execution. Now coming to the third important point we need to understand here is how the address space will be created. So the third one is address space. So in this also we have two approaches. The first approach is P. Let us consider P1 is the parent process. P1 is creating P2. Now exact duplicate copy of process will be created, and that is called as a child process. But here understand, process IDs will be different. Whatever P1 we are doing, no, the same program can be created as one more child process and the same task can be assigned to P2. So P2 is, that means we can say here, child is duplicate of parent. But understand here, even though they both are performing the same task, like you can see one example, in the browser we are creating multiple tabs. Are you understanding? Even all the processes are same, but we cannot say they will be having their unique ID. Okay, so that is the first thing. Second one is child. The P1 is creating one child, and that child is a new process that can be loaded from it. Okay, so child has a new process to be loaded into it. So the work of the child and the work of the parent both are different here. Okay. So that is the second case. Now, whenever we want to create a child process, how these are all the three different things we need to understand, like resources, how they are managing, how the execution option will be, how the address space will be distributed between the things. But whenever a parent want to create a child process, in Unix, what is the function we are going to use? What is the system call we are going to use? In Unix point of view, the system call that we are going to use is fork system call. Okay, so we'll see Unix example. So in this, you can see the system call that we can use is fork system call. So what is the use of this fork system call is to create a new process. So which is nothing but a child process. Okay. Now, if you want to assign a new task to that, exactly that a duplicate copy of the parent will be created. But if you want to assign a new task to the process, then you can use another function called exec system call, where a new task can be assigned to the child process. But always remember, fork will help us to create a child process. Where this child process can be assigned to a new task by using exec system call. I hope you all are understanding. So to understand this one, you can see a simple diagram is there here. Let us see this diagram first. Now, is this clear to you all? Is this visible to you all? I think you all can see this diagram. Can you all see? Is this clear, the text in the diagram? The text in the diagram is not clear. I'll read out. Okay, see, understand here. Now see here, we have one process. Let us start. We have started one process called a parent process. This is a parent process. Okay. Follow carefully. Now, whenever the parent process is creating, that is in our case, let us consider P1 process. Okay. This is the parent process. Now, whenever P1 is executing, at some case, it wants to create a child process. In that case, it has to call a function called fork. Fork is a system call. That is what it is calling. Here, the parent is calling a fork. Now, whenever the fork is created, then what happens? No, the diagram will be like this. Understand? P1. Whenever it is calling, no, it will be creating one parent, one child. Let us call which is P2. And similarly, we will be executing P1 also. Are you understanding? This is not the tree structure what I'm talking here. This tree is about parent-child creation. Here it is about the execution, how it will be done. Whenever P1 is executing fork, what happens? A child process will be created and also parent will be executed. Are you understanding? So a new process will be created and that will be named, and then after that both child and parent here, both parent and child will be executed. Okay, and they will be continuing their execution. Now, if a new task you want to assign, I told you know, whenever for a child, if you want to assign a new task, you need to use a method called or a system called exec. FOR key is a system call to create a child process. To that child to assign a work, you need to use a exec. What is this exec function? I'll tell you. Understand, exec function is nothing but a child process will be assigned to a new task. So how to assign the task and all is exec is a function. Okay. In that you need to pass some parameters. 3 parameters need to be passed. First parameter is where the file is available, on which file you want to perform the operation. Second task is what type of command you need to perform, and you need to pass a parameter called null saying like it is a successful completion. Understood? Once this task is done, it has to execute the exit command stating like my work is done. So what is the operation that is assigned to the child that has been done, that will be told to the parent process by using the exit function. Now while going through the exit function, it will be carrying a value called null. What is meant by null? Yes, what is the meaning of null? Null is nothing but this execution of the child process is successfully done. I'll tell you once again. Understand? So understand what we are doing. Suppose we are executing one process, parent process. Okay. Now the parent process has executed a method call or a system call called fork. I told you know what is the use of fork system call. Fork system call use is to create one child process. That means we are executing now P1. Now P1 has created one child called P2. Let us consider. Now along with P2, P1 will also be executed. Understood? That means parent and child both will be executed. Now for P1, if you want to assign a new task, you can go with exec system call where whatever work you want to assign to P1, that P2 can be assigned. But remember, whenever you want, normally we can use duplicate copy like P1, whatever task is done, the same task can be assigned to P2 also. But if you want to assign new thing, then you can use this exec function where new task can be used. How that can be assigned is with exec, you can it is a function where 3 parameters can be passed. First parameter talks about the file where it talks about the path where the file is available. This will be telling about the second parameter talks about the command, and the third parameter is null stating like successful completion, like exec has been successfully completed. Okay, now here the parent can continue its work and child can continue its work. Suppose if you have a second scenario where parent has to wait until the child work has been done. In that case, parent has to wait until it's get a signal from the child stating like my work is done. Now you can continue with its work. Continue with your work. Okay. In that case, what happens? The child is executing the thing, and once its work is done, the child has to report to parent using an exit command where it has to pass a parameter, third parameter stating like my work is done successfully. So once the parent receives null in the wait, then it understands like yes, I have done my, the child has done its work. Now I can resume my work. Got it? So this is how fork and exec systems calls are used in parent-child relationship. Is this clear to you all? So this is how the process will be created. To understand this one very even more clear, always remember I told you know fork method will be called. This fork method can pass 3 values. Always there may be a chance of passing 3 values. First value can be less than 0. Always integer value it will pass. Okay. It can be equal to 0 or it can be greater than 0. Suppose the fork system call, whenever a parent is calling fork system call and it returns a less than 0 value, it is nothing but there is an error in the fork system call. We need to try once again. Suppose if it is sending equal to 0 value, it is nothing but the child process has been successfully created and we can go with exec function. So this is successful creation of the child. Whenever the fork system call is sending greater than 0, it is nothing but it has not created the child child process, we are in the parent process only. Understood these three values. Now we'll see one simple program where this process creation total process will be reflected. You can see this diagram. Okay, let us not bother about all these header files and all. This is a simple C program where we are talking about how the parent process will be creating the child. So in the main method, I told this is one parent process, let us consider. Okay, P1. Now P1 is executing one method called fork. Now this system call, whenever we are creating, this will return some values. What type of values? It can be less than 0, it can be equal to 0, it can be greater than 0. This fork. Okay, so that value we are storing in a variable called PID. Now we are checking PID with three different cases. Understand here. What is the first case? If PID is less than 0, you are displaying an error stating like fork, there is a problem with the fork. You return and you can try once again. That is what it is told here. We'll see the second case that is equal to 0. Suppose if PID value fork is successfully executed, we did not get any negative value. If its value is equal to 0, that means we have successfully created the child, and then we are assigning one task to the child. So how can we assign the task? I told exec is there. Different versions of that exec is also there. So exec lp is one type of system call where we can assign one work to the child. So I told three parameters can be assigned. First parameter talks about the path where the file is available. Like if whatever command you are executing, that path has to be told here. And then null value is to be sent. Why? Because once successfully is done, this value will be passed there. Okay, and we'll see the third case. What is the third case? If the value is greater than 0, if the PID value is greater than 0, you are in parent process now. Wait until you get null. When you will get null? Only when we saw this diagram. No, once the child process execute the thing, then only it will be passing the null value. So once you get the null value, then you can say it will be telling like parent is completed. Then you can continue with your execution. Are you understanding? I am considering the second scenario where the parent has to wait for the child. This may not be the case always. Both can be executed concurrently also. That can also be done. But if you want the parent to wait, then this method has to be used, wait method. Is this clear, all of you? This is a simple program. This completely talks about how a parent is creating a child and how the flow of execution can be. Okay? Like in our lab, shell programming, during that lab period, you are going to use this fork method, wait method, all these methods. System calls, your next fourth experiment is using system calls only. Fork, wait, all these things. There it will be very clear to you how the execution process and all will be done. Okay? So you need to understand fork will be returning 0, then only the child process has created. Okay? So this is about process creation. Okay, so the second operation we have is process termination. So process termination. We'll see about process termination now. So we have done our work. The child process has given the null value, successful exit from the child process, and now the parent process can resume its work. Now once it is continuing and its work is done, how can a parent process can terminate a child process? Okay, that we'll see. So keep your heading, all of you. Process termination, second case. Okay, process termination is nothing but killing of a process. So once all your works are done, the process has to be completely removed from the main memory so that another process can be copied into the main memory, so that we can execute the another process. If the process is not terminating and throughout the time it is there in the main memory, we are wasting our main memory space, right? So once the work is done, it is our responsibility to bring back. It's not like the operating system responsibility to bring that process from that. Another process can be loaded into the main memory. Now, how can we do that? Suppose if you are telling like the process has been successfully executed, then that can be told by passing exit0 method. It is nothing but successful execution. Okay, it is used to exit the process. If this is to be last statement in our program, wherever you are having the process, no, this should be the last. If some cases we'll be writing exit 1 is nothing but it is unsuccessful execution. Exit 0 is nothing but we are telling like it is a successful execution. It can be a parent process or it can be a child process, whatever it can be. Okay, so this is the way how naturally the process is exiting. But sometimes the parent process wants the child process to be forcefully terminated. Like suppose the work that is assigned to the child process, sometimes it is not required. Further, it is not required. The P1 is creating P2 and some work is assigned to P2. Now P1 thought like the work assigned to P2 is not at all required further, no longer required. In that case, what we can say, the P1 can forcibly remove or forcibly terminate this P2. So that is called as forcible, and to do that one, we can use abort system call. Abort system call is nothing but forcibly we are terminating the child. In that case, the parent can be terminated. Otherwise, we cannot say like and child is it's doing its work and parent can be finished. No, that is not the case. Got it? So this is the two techniques we have. These are the two techniques we have to mention the process termination. Abnormal and normal ways. Okay. Got it? I hope this operations on process is clear to you all. Two types of operations can be created. Process creation, process termination. So in detail about this fork and all, while executing the lab task, it will be very clear to you. Okay.